Hello, and welcome to CNE's Virtual Technology Showcase, Machine Safety Solutions. I'm your host, Yancey Wilcoxon. I'm the Regional Sales Manager with CNE Advanced Technologies. The format today is a live event, and what does that mean? It means that we are broadcasting out live, and because of that, you can hear us, but we can't hear you. Even though we can't hear you during the live event, you can be heard via the Q&A chat button located at the bottom right of the event window you're viewing. I'll be monitoring questions and asking immediately if it makes sense. Otherwise, I'll review them at the end. Joining and helping me today are Chad Bramer, Banner Engineering Area Sales Manager, Shane Evilsizer, CNE Technology Consultant, Steve Wright, CNE Safety Specialist, and last but not least, our keynote speaker, John Klusk, who is the Senior Product Manager of Banner Safety Products. And with that, on with the show. Over to you, John.
All right, thank you, Yancey. Great introduction. So thanks everybody for joining us today. Really excited to go through what we have from Banner Engineering over the last year and a half. We've introduced some really innovative products that really are game changers in the industry. And before we dive into that, let's do a quick kind of overview of who I am, what I do. So again, my name is John Klusk. I'm with Banner Engineering. I'm the Senior Product Manager. I handle all of Banner's safety products. And what that means is I do voice of customer research to determine what customers need. Use that to then inform our R&D team of our product roadmap and the inputs needed to create the great products that we introduce. And the outcome of that is our products that really differentiate things for our customers in the marketplace. And we have a couple of those examples today. The SC10 is a safety controller we're going to talk through, and also this new feature called In-Series Diagnostics. So overall at Banner, what our safety team's objectives are really to innovate, to solve customer needs. So like I mentioned, I do voice of customer research to figure out what those needs might be. And then when we develop solutions, we want to make sure they deliver value and they're also easy to use. And you'll see that in today's presentation. So overall, what I'm responsible for in Banner's portfolio are a lot of products. We have some great safety products. We're not going to hit all of them today, but Banner's known for safety light curtains. We have products that can detect fingers, they can detect hands, they can detect ankles. We have grids that detect bodies. We even have solutions for grids that can be plug and play to do muting on the input and output of a cell like you see here. Banner has been known for our two-hand control product. You see these all over the globe. We have a great lighting and indication assortment as well that ties in very well with our safety controllers that can control not only safety, but also the illumination within your cell to create a really cool experience to help you know what's going on for local diagnostics. Banner also has safety laser scanners. We introduced this product about just over a year and a half ago. And this is a fantastic laser scanner. It has a interface on the front that tells you what's going on at the system, so you can easily diagnose what's going on. It has some great overall features. Later on this year, we'll actually be introducing a few more models, so stay tuned for that. But really what we're going to talk about today is Banner's safety switches. We've innovated this space in a new way with In-Series Diagnostics. Same goes for illuminated EStops. We've had this product for quite a while, for about 6 years now, with illumination built into the EStops for local indication. With ISD, we're changing the game, and we're doing that with our safety controllers. So before jumping into ISD, we have when I was out doing research, I noticed something in the cabinet that was pretty apparent. There's a lot of relays used in different ways. You can see in some cases there's a lot of wiring. It's kind of a mess. You're using multiple relays with wiring, and in this case, lots of relays, contactors, and a significant wiring mess. And there weren't safety controllers in these applications. And I had to say, okay, why aren't we able to get in there and sell an expandable safety controller? You know, Banner has been developing, manufacturing their own safety controllers for well over a decade. This is our second generation version, the XS26. It's a great product. I went out, talked to our customers, said, hey, what's your feedback on the XS26? What do you like? What don't you like? And overall, across the board, what they really love with this product is the PC software. First of all, it's free. It's easy to use and learn. And actually later on in this presentation, we're gonna have Shane show you that. It's so easy that even a salesperson can do it, right, Shane? so we'll go through that. It's flexible as well. So I mean, overall in this system, you can have up to 154 safe inputs, 68 safe outputs. So it's super flexible, and it's also smart. In this day and age, having a controller that can speak to the PLC, and we have the most common protocols, Ethernet IP, ProFiNet, Modbus, is really important. So they love that. So then I said, okay, well, when I look over at your simple machines, I notice you're not using the XS26, and why is that? And when we looked at it, we said, hey, like in this cell here, there's a robot, there's a light curtain that is here to stop the robot when somebody's hand is maybe adding material or removing material from the machine. And that's hooked up to a safety relay that's designed for light curtains. And then there's also an EStop, and it's connected to the second relay. And that second relay is going to basically stop the entire machine if something bad happens. So then you ask the question, well, why didn't you use a safety controller? And the simple answer was, well, when I look at 2 safe relays, and this is list price, right? We're looking at $300 to $500. When you get into an expandable safety controller, the cost just didn't make sense. So I brought that back to our team and said, hey, you know, we learned people love our XS26, the free software. It's easy to use. They love that you have all these safe inputs. You can configure the safety outputs. I mean, there's a ton of safety zones. You got 6 amp relays, you know, half amp. Actually, most people buy our 6 amp relay module, and they love this. But we need something that can fit in between. Because I said, and I showed the team, I said, hey, we've got, looks like I clicked too many times here. So on one end of the spectrum, you have safety relays. And the way they're set up is they are built with fixed logic. And what I mean by that is, like in that last example, there's an EStop relay, and it has its own logic that works with EStops. And then we have another relay for the light curtain, which is a different relay that has its own logic and works with that type of device. And there's 2-way control relays and all that. So you got to pick the appropriate relay and also the function that you want it to do and stock that and use that. On the other end of the spectrum, you got expandable safety controllers. You can configure the logic, but really the price starts to make sense when you get to like 3 or 4 safety relays, when they start really adopting expandable controllers. And that's why we invented this product called the SE10. And this is a hybrid. It's a safety controller, so all the cool stuff you get over here, but we built in 2 independent 6 amp safety relays. So we took 2 of these things, we stuck them in the right side of this box. So the top one here, safety zone 1, 6 amp relay. Bottom one here is a separate safety zone 6 amp relay. And you have 10 inputs that are configured with the same great software you get over here on a PC for 10 inputs, and it has industrial Ethernet. So we made this thing smart, Industry 4.0.
Hey, John.
Yeah.
What's the rough size of that SC10 width-wise?
You know, it's the size of 2 standard safety relays. So it fits right in that same place as 2 standard safety relays. Great question. That means, so Yancey, you're paying attention too. This is great. So in the SE10, again, this product, it uses that free PC software. It has 10 inputs, and it's 2 safety zone outputs. Safety zone 1, 6 amp relay. It has 3 normally open sets of contacts. Safety zone 2 is a separate, independently controlled 6 amp relay with 3 normally open sets of contacts. It has industrial Ethernet that speaks the most common protocols: Ethernet IP for Allen Bradley, ProFiNet for Siemens, and Modbus TCP for, you know, a whole host of other PLCs. Now, the other piece of feedback we heard in research was, you know, I love the you know, for relays, what they really love about them is they're very easy to set up, and then when they need to be swapped out, you don't have to bring a PC out for that either. With a safety controller, the concern of a controls engineer was like, hey, when I got to set up this machine, I'll have to drag out my PC to set it up. Or when it gets installed, I'm going to get a call at 3 a.m. from the maintenance worker saying, hey, I got to swap this thing out. How do I program it? So I brought that back to the engineering team and said, how do we fix this? And what we did is the controllers, both of these controllers have memory built into them. But we made this thing called an XM3. So it's a removable memory device that you can store the safety configuration, the passwords. This is password protected, right? So you don't want people going in a safety program and changing things. It's password protected. And also the network settings. Whenever it gets its final network settings, the SE10 will push that into this device. So what's really cool about that is when you go to build your machine, you can stock one of these things, right? The SE10. You don't have to have 12 different types of relays for all your machines. You got one SE10, and then you can create a bunch of these XM3s with the part number, put it in stock, and you never have to go out as a controls engineer to the line and go program again. This thing's out there. The panel builder sticks it in, powers it up, boom. It's got it has what it needs. It's ready to run. Then when it goes, and you can actually leave this device in the SE10, it'll work through vibration and everything. We tested it. So when you drop this thing into its final destination, when they eventually have to swap it out years down the road, grab one of these out of the crib, take this thing out of the old SE10, put it in the new one, put your wires in, you're back up and running. It's as simple as a safety relay. Now it's a mechanical installation just like a safety relay. And that's on the SE10 and on the XS26. So we developed this product, the SE10. We introduced this last year, and we went back out to the same customer and said, okay, here's what we can do now. So instead of those two safety relays, you can replace it with the SE10, same size. So it's a 45 millimeter safety controller. For the light curtain, you can plug the light curtain into 2 inputs on the SE10. Again, you have 10, right? So that is then mapped to safety zone 1, that first 6 amp relay. And then for the EStop, depending on how you're hooking up your EStop, you got 3 to 4 inputs, and that goes to safety zone 2. And you still have other inputs available if you want to control the light on here, because you can actually turn these inputs to outputs to control lights. You can do a lot of other stuff with the available inputs. The other thing is you notice there's a button on this machine that they're using for the reset. So once an EStop is pressed, you rearm it, you got to have another means of resetting that system. You can replace this physical button and do it from the touchscreen HMI with a virtual reset to the SE10, saving additional cost. Oh, and then also Industry 4.0, we got diagnostics to the HMI and PLC because this thing can speak the language of a PLC. So when you look at the overall value that the SE10 delivers, it has a significant cost savings even on the simple machines. And this doesn't take into account the wiring savings, this $150 per machine. The wiring savings, if you're doing diagnostics, wiring can be quite a challenge, and even on a simple system. And also the simplified inventory, and that you can use the same controller across all your machines and not have to stock all these different types of relays. Now, when you go into a little more complex machine, and you got a case, in this case, it's a case erector, and here you have 2 light curtains. You got a light curtain on the input, light curtain on the output. You've got a bunch of EStops and door switches. In this case, there's one hazard, right? You've got the hazard inside the machine. If a light curtain is tripped when it shouldn't be, or if a door's open, the hazard in here will stop. So that's safety zone 1. And then you got EStops in case something bad happens you didn't expect. You press that, that's safety zone 2. Well, on a traditional system, that's going to require 4 safety relays. The reason for that is I need a relay for each light curtain, so light curtain on the exit and the entry. Because the EStop has its own safety zone, it needs its own relay. And all the door switches need their own relay as well. Now you also notice I did in this case, they've run wires home run from each device back to the panel. And the reason they're doing that, if you look up here on the HMI, what they're doing up there is they're showing the status of each of the EStops and each of the doors. And the way you do that is each device has their safety wires that go into the safety relay, but they also have auxiliary wires. And you can hook those auxiliary wires up to the I/O card on a PLC. So I got 5 EStops, all auxiliary, all 5 auxiliary wires for each of those EStops goes into 5 I/O here in the PLC. Same deal for the 6 door switches. And then the control engineer doing the programming for the PLC, they got to map the auxiliary inputs from the I/O card to the PLC to the HMI, and you get this cool experience. So that's kind of what's going on here. With the SE10, we can drop all 4 of those relays, replace it with something half the size, and save a lot of money, and also add Industry 4.0 diagnostics over Ethernet IP, ProFiNet, and Modbus. So there's a huge advantage just with the SE10 on this machine. And that advantage you'll see here. So we're just replacing more relays compared to what you saw in the previous example. So there's even more savings, even better increase or better utilization of inventory. It has all the same advantages, just more money saved, less relays. So with the SE10, we went back and talked to these customers, said, safety controller now, why not? And really what they said is, I totally agree, because what we did with this system, we have a list price on the SE10 at $450. So it's positioned where really for most machines that are using 2 safety relays, there really isn't a reason to use relays again. This thing can replace all that, simplify your life, make changes a lot easier, and give you an Industry 4.0 diagnostic solution. And this has been just a game changer across the industry. So in that same same discussions, we noticed the wiring, all those wires there. It's like, wow, that seems like an opportunity that we can help innovate and make that easier, because really what the customer wants is they want to know what product, what EStop was pressed, what door was open, so they can reduce downtime, right? That's the whole purpose of this, right? So we said, but the challenge they have, and I talked to a number of machine builders, and I go out and we'd be in the lobby waiting for the controls engineer, and he's troubleshooting this exact issue, wiring. All these wires going back, trying to figure out why on the screen, when I press this EStop, that one's turning on. Well, I got it hooked up in the wrong spot. That can waste hours, days. Sometimes I've talked to folks, if they have a lot of doors, that can be weeks. And that can delay shipping on a machine. So let's say, hey, let's look into this and figure out how we can fix it. So we have a solution now with in-series diagnostics that'll clean up that wiring mess. It'll also eliminate an I/O card in the PLC. It could be multiple if you have a lot of doors. And we're doing that with this feature called Banner's in-series diagnostics, or ISD. And the way this works is we have Banner devices with this diagnostic protocol built into them, and they speak to the SE10 and directly to the PLC. So for all the door switches, you simply connect the door switches with, if you're looking at my video, we've got this simple T connector. 4-pin cables connect to it to connect each device. So it's simple. There's nothing special about the cables. We have great cables, but nothing special about the cables. 4-pin cables that connect the T connectors together. 2 of those 4 pins go into the SE10, and the other 2 go to power. You can have up to 32 doors on this chain. In this case, they have 6. The EStops, they also, starting in about a month, will have ISD built in to them. So you can do the same thing. That same T connector connects to the EStop, 4-pin cables, connect all the EStops back into 2 additional inputs on the SE10. The other 2 go to power. And all this information that you get up here, we just send that over either Ethernet IP, ProFiNet, or Modbus to the PLC. You don't got to go in and configure all this stuff. And we even made that setup really easy. I'll talk about that a little bit more. So when you get down to this system, now we can even drop an I/O card, so there's additional savings. What's not on here in the cost savings is the wiring. That's a big deal. That's going to save a lot of cost, a lot of time troubleshooting, get more machines out the door. The other thing I didn't mention, so we can reduce downtime. We tell you what device is pressed, where it's located, preventing downtime. There's no one else that can do this on the market, and with ISD now you can. And what I mean by that is we can send an alert to let the maintenance person know that they need to go and adjust something before you have downtime. And I'll show you what that means here in a second. But this is really a game changer. And really, simply put, kind of what's going on here is these devices, the RFID door switches and the illuminated EStops, have this protocol ISD built into them. They speak to the SE10. It does all the hard work and then makes it very easy for the PLC and HMI to understand what's going on with the system.
Hey, John.
Yeah.
I don't know if in your live demo you're going to show, but another thing, prior to ISD, our illuminated push buttons were a great indicator of which push button was mashed as well. So that may be a good point to bring up to the audience.
Yeah, so you're saying that as far as like the current illuminated EStops, or are you talking about a?
Yes, that
Yes.
when they're in series without programming them, you know, they're all, say, a steady yellow. When one's mashed, the one that's mashed is a flashing red. The others are steady red.
Absolutely, yeah. We'll show that in the demo. I think I have a slide here that'll show that exact thing. So that's exactly it. And Nancy, I get so excited about ISD, I forget about the local diagnostics that you get with this thing. But yeah, when these things are connected together in series, the device pressed will flash red. So you can locally see what's going on. And then on the HMI, even before you have to go do that, the HMI is going to show you where it is, what it is, and then you can quickly get to that spot on the machine, figure out what happened, and get that machine back up and running. That's a very, very good point. So you look at what we can do with this, with the ISD system, reduction of downtime. That's going to tell you if the which device was pressed, where it's located. That's what you're doing with wiring today. We can do that without all the additional wiring. Preventing downtime, the RFID door switches can send an alert when they're right on that edge of being open, like a door starting to sag. It'll send an alert saying, hey, you want to go adjust door 3, it's at 13.8 millimeters. That's pretty phenomenal. I'll show you that in the demo. Voltage, if voltage gets too low, it'll tell you where it is, and you can go address that before you have a problem. So maybe it's a power supply issue, maybe it's a wiring issue. You can go and fix that. Temperature, that's another indicator. Maybe you put the thing in too hot of a location, everything else is working fine. It can help you out with that. Reducing cost and time. We already talked about the T connectors and 4-pin cables. That's a substantial savings. Expediting the machine build, no longer having to deal with all the wires. But the thing that we show this to controls engineers, like, yeah, that's cool, but how do I get all the tags set up? That's going to be a lot of work. Well, we have a solution for that as well, and we'll show you what that looks like when Shane goes through his demo. Shane's got this thing; he's going to knock it out of the park. And again, it's a sales guy, right? All right, so on the illuminated EStop, so what we have, this product has been just an amazing growth engine for Banner. We sell a ton of these things, and why people like them is the local indication, as Yancey mentioned. Like in this example on the conveyor, this customer chose to use yellow to indicate when the device is armed. You can get it in green or even off if you want. But the one in the middle is the one that's pressed, because that'll flash red. And the way that works, and here's my terrible animation, is if I press this one in the middle, it's going to flash red. And in this case, the customer's using green to indicate it's armed, right? So you can locally see what's going on with a flashing red. You know that the other ones are powered or good to go. And it's only 4 wires. Power goes to the system over 2, and then these are OSSD outputs, just like a light curtain. Highest level of safety, goes over 2 wires into the SE10 for safety and this ISD diagnostic message. So in a system, and I show this isn't really a typical way that you hook these things up, but I show this on purpose. We can get up to 64 ISD devices into an SE10. You think about that, $450 list price product can have 64 ISD devices hooked up to it, and it still has 6 additional inputs available for other stuff. I mean, that's the most densely populated controller on the market. And the way that this works is you have 2 separate safety zones, or ISD chains. Each chain can have up to 32 devices, and you can mix and match EStops and RFID switches if you'd like. In the example I showed before, you're more than likely going to have a chain of all EStops and all RFID door switches. And the reason for that is the way that the ISD works is you're daisy chaining devices together. It's like cascading light curtains. So the OSSDs from this one go into that one. And if that one is not okay, it's going to tell the rest of the chain to turn off. So the OSSDs for the entire chain will be off if any one device is off. Now, ISD tells you where that issue is so you can quickly address it, or it alerts you when there's something that may cause an issue so you can address that and prevent downtime. So, you know, in that other example, then what we did is we mapped all the EStops into safety zone 1, turning the power off when something bad happens. All the door switches went into safety zone 2. And then we have the other inputs for those 2 light curtains get ANDed together with this ISD chain to control that safety zone 2 as well. Oops.
Hey, John, I have a quick question that I missed a little while ago. Question is, will Banner eventually connect via the Mitsubishi Network CC Link IE field? Is that on the roadmap?
That's on the roadmap to add additional protocols for sure. In this year, I can tell you we won't have that. But yeah, we're looking at additional expansions. Right now, it's Ethernet IP, ProFiNet, and Modbus TCP. And the amazing thing about this is you don't have to. First of all, on any other product in the market, you have to go to an expandable controller to get these protocols, and you have to buy a separate, specific slice for that protocol. Banner, we build it into the base unit. So you simply select what protocol you need in the software, and away you go. So you can be flexible for different machine types. Customers want to switch over to Siemens or Allen Bradley, or you want to do your own homegrown deal over Modbus TCP. You have that option in the software to just select it, and away you go.
And another one that just popped up, which I think I know the answer, but you can correct me if I'm wrong. It's what if I have a non-ISD device, and then you will need to just hardwire it into your additional inputs. Is that correct?
So there's a couple different ways you can approach that. So yeah, if you have a non-ISD device, let's say it's a light curtain, like we did before, you're going to want to bring that light curtain back into the SE10 directly. I mean, that's going to give you the best response time and all that. But what I'm going to show you in this demo, this is like kind of a little sneak peek into what we're going to be doing here soon. It's not on the slides, but this is a new feature. So if you look at, here's the T connector that we're using to hook up ISD devices. And this thing's just slightly bigger. What it is ISD, it's called ISD Connect. So at the end of this year, we'll have this device that you can add in as one of the 32 devices, or you could have 32 of these if you'd like. What you can do with it is hook up 2 sets of normally closed dry contacts into the input of it. So an example of that would be like, a panel mounted EStop or a mechanical switch. It goes into here. And then this device turns it into OSSD outputs to add it to the chain. So you get the highest level of safety. It self-checks, does all that fun stuff. And it gives you the diagnostic status over the ISD chain. So you will, at the end of this year, have another option. And this thing, and you'll see in the demo, it has some lights that turn on and off to tell you what's going on. It's a really cool system. All right, so. And I'll show another bigger view of that in the demo of that feature, in case my video isn't all that large for you to see. Now this is how a system's constructed. It's really simple. You start out with the termination plug. All it does is it runs 24 volts into the first device, and then it's T connectors that connect the devices, 4-pin cables between devices, and 2 pins go to the SE10, 2 go to power. Now we also have devices that allow for a local reset. So if you want to have a reset button wired in here, you can do that. Same goes for the EStop. But really, this is the most typical way to hook it up. You've got a termination plug, T connectors, 4-pin cables, and land them back to the SE10. Now, a question that will also come up is, well, how many devices, how long of a cable run can I have? Because obviously, you run into challenges with power. Well, what's really neat about this system is really the only limitations that we have are 32 devices per chain. I think I said that a few times, right? But it's 32 devices, and there's like a 30 meter limit between here and here, but that's very unlikely to see that, right? Other than that, there's no cable restriction. All you do is you add power where you need to in the chain. And with ISD, it'll tell you where. So when I hook up all these devices, it'll say, okay, they wouldn't really do this in this view of devices, but what you'd be able to do is you can either add power to replace the termination plug, or you grab a T connector and you add power somewhere in the chain, and ISD will tell you where. Really cool. And then as far as, the system, it has a very simple user interface, and Shane's gonna knock your socks off with this demo, right? It's gonna be amazing. And then we also have this export tag feature. So with that, I'm gonna switch over to a software demo. Unless Yancey, you had any other questions you wanted to pop in while I'm doing this quick transition. I'll take that as a no. All right.
Sorry, my mute button went it disappeared on me, but no, there's no questions right now. We're good.
All right, great. That's awesome. All right, so what I have on the screen here is Banner software. So we have this tab here for in-series diagnostics that shows all the devices in this actual live demo. So in the demo, kind of like you saw in that case Erector, I only put one light curtain in. You could have a second, but I've got that hooked into it. What we did for ISD is I have two separate ISD chains. In this first chain, like you see up on the screen, we have two RFID door switches. Door switch 1 and door switch 2. It's connected with a termination plug, T connectors, and a 4-pin cable. 2 wires go into the SE10. Over here on chain number 2, this is that I'm gonna do a close up. We'll see how this blows up. Right, so this is a prototype with a handmade label. This is what I got from engineering to do this, but it's a little sneak peek in the future, right? So this is the standard T connector you hook up to ISD devices. This is ISD connector we were talking about earlier. I've got a prototype down here that's hooked to this panel mounted EStop. Okay, so that's device 1. You got termination plug goes into it. Then I've got two EStops, illuminated EStops, because we sell this both in a 30 millimeter round, so you can put a 30 millimeter hole in your panel, drop this thing in, hook it up. We have brackets and stuff too. Or you can do a flush mount design where this thing just mounts right to the machine. There's 4 holes for it. Now, if there is a need on our round, we have a wash down cover as well that you simply just add this cover over the top of the device and you can spray away, clean it up. It's all good. So the way the system works, you watch kind of both the screen and the video. So it's going to tell you when a device is pressed, if a door is open, and that gets sent. You'll see here I've got this round EStop is pressed. The OSSDs are off for that system. Over here, this chain 2 is also off because that door is open. Now I mentioned you also have, and I can go and remove my reset. In this case, I'm doing a hardwired reset. We're turning the light on and off of the SE10. It's a pretty cool system. But here, the other thing I mentioned that we have the ability to prevent downtime, and with the unique door switch, I'm going to put this here out to. So with our unique door switch, what it's going to tell you is that it's in this marginal range. So the OSSDs are on. That means everything safety-wise, it's like, hey, keep running, everything's good. But you're going to send an alert to the PLC, the SE10 will say, hey, go check out door 1. And then the PLC can say, okay, great. Hey, door 1, tell me what's going on. And on door 1, it'll say, look at this. I'm at 14 millimeters. 14 millimeters, right? I can tell you that 13.8, 14 millimeters, right? So then it can also tell you the voltage level, 24.2 volts. It'll tell you the temperature. And then the other thing you'll see, it'll even tell you the actuator code. And now where this is really cool, so on the uniquely coded one, this one's expecting to see the 8E37, and it sees that, and it's great, right? We also, so uniquely coded, that means you train the actuator or train the sensor to only recognize that actuator. Each RFID code from Banner has a unique identifier in it, right? So the uniquely coded, you train it, boom, it's the only one that it'll use. Now we also have a low coded sensor. So I'm going to show you that one because what you can do with ISD data that's pretty unique is that for this low coded, it's expected code. This it says 1, 2, 3, 4. It'll take anything. It doesn't care. So as long as it's a Banner RFID actuator. So this one right now sees ACEB. Now I can take this uniquely coded actuator, replace it here, and what you'll see on the screen is we have this thing that says actuator detected. It'll send that to the PLC and say, hey, I see an actuator. The PLC can say, okay, great. Now it sees that 8E37. Now this isn't high-speed RFID tag reading by any means. What this is it's a couple of seconds, right, to get it. But what's really neat about this is you think of what you can do with this. Maybe I have an application where I have, from a process standpoint, I want to know what tool is in the machine. I can do that. So I add the tool in, I see it's the right one with my low-coded sensor. Then on that same chain, I've got the safety guard that I uniquely coded because I don't want people tampering with it, right? And all that goes back over the same two wires. So I can get process data from the low-coded to make sure it's the right tool to run so it doesn't damage the machine. And then for the other one, I can have safety. I can hook EStops to it. I can hook whatever I want, up to 32 things. So that's a really powerful use of the system. Now we also have, for the EStops in particular, I mentioned the voltage. I mean, in this case, my voltage is great. I got short cable runs and a power supply that's hooked right up to it. But anyways, I'll tell you the voltage level. But now for troubleshooting, if somebody forgot, and this has happened even in some of our earlier tests, someone forgot to put the termination plug into the system. Well, this could be buried in the machine. And this could either be when you're doing the initial build, or it could be when you bring this machine out to the machine goes out to the customer, and someone realizes, they get smart, maybe they watch an ISD presentation by me or something, they figure out I can take this thing out and I go on break. Well, you can quickly identify that on the HMI because you see on the screen terminator missing. And we actually have a bunch of info in this system to tell you what's going on. So you can have the wrong number of ISD devices where that's important. You think about somebody also not only trying just to go on break, but let's say that one of the doors in the system, they're like, that's slowing me down. So I'm going to take that door out of the chain and reconnect things. Well, it'll send an alert to the PLC saying I got the wrong number of devices, wrong order, since you can do EStops and RFID door switches in the same thing, or this ISD connect. If it didn't match what you said, it'll tell you. And it has a bunch of other information like wrong actuator not taught. If you get unique or high coded sensors, it'll let you know if the actuator wasn't taught and where it is. And the whole idea here is getting machines out quicker and reducing downtime, even preventing downtime. That's what you get overall with ISD. So before I switch over to Shane and show, we can have the sales example of how to actually set up the system. Any questions, Yancey, you want to pop in before we do that changeover?
No, we are good on questions, and yeah, we're at the 10:35, 10:38 mark, so I think we're good.
All right, cool.
So with that, Shane, you are up.
Hey, good morning, everyone. Shane Evilsizer, technology consultant for C&E, covers a portion of the Dayton area and surrounding areas to the north. Like John said, I'm here to demonstrate the functionality of the Banner Safety Controller software, which is a free download from their website, bannerengineering.com. This software is used for configuration and simulation of the of safety circuits using the XS or SC26 series safety controllers, or the SC10 hybrid controller relay. So for today's application, we're going to build a 2-zone safety application using the SC10, which, like John said, has 2 logically independent 6-amp safety relay outputs. So we'll jump right into the software. When you open the software, you are prompted to select which controller you'll be using. So we'll go ahead and select the SC10. And you can start by adding your safety devices. You'll see a number of tabs up here across the top, some of which we'll be discussing here today. You can add your safety devices from either the equipment or functional views. So we're going to go ahead and do that from the equipment view. So we'll do so by just hitting this plus sign here. That'll give us all the safety device options and the non-safety inputs, status outputs that are available for use with the circuit. So we're going to set up an EStop that turns off both zones and then won't allow them to open back up until a manual reset function is performed. And for that, we're going to use a string of ISD EStops. Best practice is to name these. Select 3 devices, make sure they're all EStops. Provide a name for each. With your ISD strings, they're automatically allocated to either terminals 3 and 4 or 5 and 6. And like John said, you can have up to 32 devices on each string. So for this case, we're going to select 3 and 4. Now you'll see our EStops are populated here and over here in the functional view. So then we'll just start adding the rest of our devices. For safety zone 1, we'll add a set of 2 ISD door switches. Doors, select the number of devices, door switch. You'll see there, like I mentioned, with 3 and 4 being taken by our EStop string, the inputs or the terminals 5 and 6 are the only ones available. So we'll hit OK. For safety zone 2, we're going to add a pair of easy screen LS safety light curtains. We'll name those as well. You can see here the various options that you could wire up the light curtains and the associated terminals that are allocated for such. If you were to click, you can manually select the terminals, or they will be automatically allocated based on what's available. So we'll stick with dual channel PNP for this. And then lastly, we're going to add a non-safe input as a manual reset button. And this is going to be set up as an EStop reset, but we're also going to set this up as a controller reset. So when you cycle power to the controller for downloading programs, that can be done just by clicking the system reset button here. And now we've got all of our devices loaded. And so you can see here in the functional view that those are all loaded up, and we'll move these around. Whoops. Move these around to make a little bit more sense for our circuit. Pull this guy down here. So now we'll start adding the logic portion of our circuit. And you can see there on the left-hand side, there's a checklist that shows you what needs to happen before this configuration would be valid. When you connect everything, you'll get a green light over here that lets you know that your configuration is ready to be downloaded to the controller, wired and deployed. So we'll start adding our logic. We're going to start by setting up a latch reset block for our EStops. Reset. And we'll pull the EStop into here and the manual push button for the latch reset. And then we'll add a couple AND blocks for our safety zones. Whoops. And these will be our zone enable blocks. Call this zone 2 enable. And then we'll assign the devices to those blocks. We'll pull the EStops into both. The doors into zone 1, the safety light curtains into zone 2, and we'll take the output side of those blocks into our safety relays. Whoops, there we go. Come over here and name these, zone 1 and zone 2, and then we'll be ready to simulate. You can see over here on the left-hand side now our checklist. We've got the green light that the configuration is valid, can be downloaded to the controller. But for the sake of our demo today, we're going to go into simulation mode. So you can do so by clicking this gear icon at the top, hitting the play button. We'll go through and reset clear all the devices. So now you can see that both zones are cleared and enabled. If someone were to come along and open up one of the ISD, the door switches on the ISD string, you'll see that zone 1 drops out. Once those doors are shut, that zone will be clear again. Same goes for the safety light curtain. Somebody breaks the light curtain, you lose zone 2, light curtain's cleared, zone 2 is enabled again. And then if one of the three EStops that we set up in the ISD string is mashed, you'll see that that drops off power to both zones, and that can only be reset when the EStop is cleared and the manual reset function is performed. So you can see that's a pretty straightforward and common safety circuit, and we were able to set it up in a matter of minutes, prove it out, and now, like I said, this would be ready to be deployed and downloaded to your controller. I mentioned some of the other tabs at the top. A really nice feature in the wiring diagram, as you select your devices and those terminals are allocated for each device, this will show you where they land on the controller. The configuration summary is a text-based configuration for each device and block, along with the associated information for each. Best practice is to print this out and keep it in the safety office in the case that you lose a controller or program and you don't have it backed up. That being said, John made reference to the XM3 external memory drive, which it would be valuable for backing up your program, and then also if you have multiple machines that are identical. And lastly, if we jump over to the Industrial Ethernet tab, you'll see here this is a multi-protocol Ethernet device interface set up on the SC10. So if we were working within a Profinet network, do an auto configure, and you'll see everything is formatted, and now this is ready for the export function to export these as PLC tags. Same would go if you were working within an Ethernet IP system. See, the structure is a little bit different, but all the information along with how we named our devices, that information is populated and then can then be exported out as tags to your PLC. So that's pretty much it for my portion of the presentation. If you have any questions, feel free to reach out to your local technology consultant to talk about any of the products, sit down and work through a safety application with you with the software. It is very straightforward, but also very powerful. And we really appreciate your time and attention today. So I'll kick it back to Yancey.
Yeah, all I gotta say is this is why I'm not a technology consultant, because I don't think I could have done that demo. But hey, we did have one question come up right at the end of John's and the beginning of Shane's, which was, is ProFi Safe in the near future as well?
Yeah, so ProFi Safe, I mean, other protocols we're looking into. Currently, it's not a 2020 plan. With our ability to do local safety zone control with the two outputs, and also communicate with a Siemens PLC, we're able to provide a lot of value with very inexpensive. But we're obviously continuing to innovate, and the innovations you saw over this presentation that have happened over the last year have been pretty profound, and we'll continue to do that in the future.
Cool. I don't think there's any other questions. So I thank John for taking time, and Shane. Also, thank you to all the participants or the attendees. As Shane mentioned, don't reach out to any of us for follow-up questions, on-site visits, demos, etc. Don't forget to subscribe to our YouTube channels. It's C&E Advanced Technologies and Banner Engineering. Excuse me. Also, coming up, we have, as you can see on the screen, we do have 4 more events coming up. One this Thursday, which is the Pandemic Proof Factory live presentation. We also have the TIA Portal 3-day workshop in Dayton, an Auto Guide mobile robots webinar, and on August 24th, an AB to Step 7 with TIA Portal 4-day workshop in Nashville. With that, thank you, be safe, and all the best. Make it a great day. Thanks again, guys and gals.